Hello and welcome to another creative coding video. Today we're going to do something really exciting and cool. If you have a look on the screen, you can see what looks like a really interesting, exotic alien landscape. You might be surprised that it only takes a few lines of code to create this, and the key to it is using the noise function that we learnt about last time. Now you'll remember noise is a less random sort of randomness, and we looked at it last time because we wanted to create textures or patterns or surfaces which weren't purely random but were a smoother kind of randomness. And I promised that you could do lots with it, and today we're going to look at creating interesting landscapes like this. I don't know if you can see the detail, but I particularly like this kind of texture with little dots, which makes it look like some kind of, scan of an alien surface from a space probe or spaceship. Let's run this code again. I'm showing you a bit of a preview of what we're going to create just to kind of get you excited. Let's run this code again. Takes a little short while to run, not too long. There you go, you've got some really dark sort of depths there and some really interesting heights over there, kind of an interesting lumpiness. It's fascinating, isn't it? I mean, you could stare at this for ages and explore it. But I think for me the most exciting thing about this is that we've got these really interesting, landscapes with really, fascinating detail. And what creates them is extremely simple. It's just the noise function controlling the surface of this landscape. So we'll do that today. I promise it's not a lot of code, a little bit of thought perhaps, but not a lot of code. So let's dive in. I'm going to close this tab because we're going to recreate it ourselves, and I'll talk through how it's done. Fantastic. Let me close that one. Great. So I'm logged into Open Processing as usual. I've got my simple.js library. They've changed the layout a little bit of the website now, so you might have to explore a little bit. The text size thing is on this third sort of tab there, and yep, I've got my simple.js library turned on. Fantastic. And I've got an empty sketch. So before I dive in, I need to just think a little bit about how to create what looks like a 3D landscape. So as usual, let's draw some pictures, and I always recommend doing this when you're developing anything sort of moderately sophisticated. Is don't be shy of using pencil and paper. It's really direct. It's a great way of organizing and helping you think. Fantastic. So I'm got my sort of pen and paper here. It's a digital one here, otherwise you wouldn't see my real one. So I'm wanting to create something 3D, but it's a landscape. How do we go about doing that? Let's deal with this idea of noise creating a kind of a surface. Now you'll remember from last time, noise can be one-dimensional, or it can be two-dimensional. In fact, it can be three-dimensional as well, and more. But we saw how two-dimensional noise can create a textured surface. Let's actually retrace that steps there. We said if I've got one-dimensional noise, if I've got random values, they can be anything, and it doesn't create a particularly realistic kind of horizon, as it were. If we have noise rather than pure randomness, then the values from a distance are random, but when they're close, when you're looking closely, they're not that different from each other, and that makes the surface a little bit more realistic and a little less spiky. So from a distance, this can be random. I mean, it will look random, but when you zoom in closely, you'll see that values that are next to each other aren't so different from each other, and that's important. So for us, if let's take a square here, and if inside this square I use the coordinates, sort of the x and the y, to feed a noise function, I might get some values which I could use either as colour, which we've done before, or as height. So I might say this point has this height, and this point has this height, and this point has this height, and this point might have this height, and this one has that height. Now, because it's not pure randomness, because it's noise, Perlin noise to be specific, those heights won't be changing drastically if we move from one to its neighbour. So it should create kind of a smoother version of a rough surface. So that's how we'll get the heights. And we've seen something like this before. In the last video we saw how we could use noise to create a kind of colours, which gives us a kind of a smoothly changing texture. So that's how we create heights. How do we make that look 3D? Well, we could explore and learn about using mathematics to, convert sort of coordinates into a 3D kind of projection with perspective and so on, and that would be correct, but it would be quite complicated and more than we need to do here. If we can take a simpler approach, and if it works, that's always kind of better, and we're going to do that. So let me draw another picture. What I'm going to do is, instead of imagining a square, I'm going to imagine a square or a rectangle that's kind of nudged along a little bit on one side, so it's kind of squished in one direction. So I might have something like this. Is that a trapezoid? A rhombus? I need to look up the actual word for what this shape is. But now that we've kind of squished this rectangle, it is actually square, isn't it? 1, 2, 3, 4 along, 1, 2, 3, 4 down, but shifted along. So I've squished this square into a different shape. Now if I have heights drawn from a regular grid, but if I then shift them along just like I did with this square, that might give me a 3D effect. So can you see here, those kind of heights that I've drawn, those kind of vertical bars, they do look like they are moving back into a distance, and the ones that are nearer the front, nearer the bottom, do look like they're in the foreground. Even though they're just drawn on a regular grid, because I've shifted them and given it what looks like a bit of perspective, it's not real perspective, but it looks like perspective, it creates that kind of 3D effect. So let me just draw something here which shows what it looks like if I didn't do that squishing. So I've got a square and I draw these heights up from positions, regular kind of positions on sort of on the square. That doesn't look particularly 3D. Well, it might, but if I shift this along, it does look a lot more 3D. Now, the reason why I've done this is because the calculation for doing this kind of shifting along is much easier. If you compare the lines I've drawn at this height and the ones I've drawn at, say, this height, you can see up here there is no shift to the right. So if I've got a position x, y, up here y is still the same, So y is still the same, and x is also still the same. Over here, so that's the xy, what it became. Over here, my y, my vertical position from here to here is still y. I haven't shifted those bars downwards, but I have shifted them along to the right. So I might say x plus, I don't know, 200. Okay, and the one here has been shifted along by a lesser amount, so that might be x plus 100 y. So you can see that the further down I go, the more I shift to the right. That's important, that's the summary of it, that's the key point. As y gets bigger, my shift in x, let my screen catch up, my shift in x gets bigger as well. Let's keep that on our little notepad and come back to that idea when we're coding. So we've talked enough now. Let's write some code. Okay, so let's start off with a grid. So we're going to use a loop within a loop. So I'm going to say repeat with 2 loop counters, maybe 0 to 500 going up in steps of 10, and let's say, I don't know, let's say 100 to 500, and the same for this one, 100 to 500 going up in steps of 10, and I'll call a function called alien landscape, which I haven't written yet. So we're going to have 2 loop counters, one counting from 100 to 500 in steps of 10, and another one counting from 100 to 500 in steps of 10, but each one of these is done for every one of these steps in this one. If you need a reminder of loops within loops, have a look at the previous video we did. So I'm going to write my alien landscape function, and it takes 2 parameters because those are the 2 loop counters. Let me start off just by drawing a little, I don't know, circle at x and y just to see what's going on. Make it small. That should give us a grid. Yep, that gives us a nice little grid. And for each of these dots we're going to draw heights, remember, going up, which is the height of that landscape. But first, before we do that, we need to work out how we're doing that shift. So the bottom of this rectangle, bottom of this square, is shifted along. Okay, so let's work out how we do that. Let's say we create a new variable. What could we call it? We could say x2 is, well, we know that it's the bigger y is, the more x is shifted along. Let's look at that again. The further down we go, the bigger y is, and the bigger this shift along the x is. So y itself won't change for these points, but x will be increased in proportion or in relation to y. So we could say y is x plus y. Try that. That's really simple. That might go off the screen, I don't know, but it's just experimenting at this stage. Let's try that. Reason that didn't work is because I didn't plot the new x2. Let's try that. There. So it did go along. It's gone off the screen, but off the canvas. But the further down we go, the further right those dots are. Now we've got the basic idea. We now just need to reduce the amount a bit. So maybe we'll say half of y. So y divided by 2. Let's try that. Okay, yeah, that fits on the canvas. So we've got a bunch of dots that were a grid on a square, and we've distorted it so that the further down we go, the further to the right they are. And this, you can see if you kind of take a step back, this could be some kind of, perspective view of a landscape, perhaps. You can see it's not really correct perspective, because the things that should be further back should be smaller and closer together. But we won't worry about that for now. We'll see if this sketch works. We can do that refinement if we need to, and I suspect we won't. Okay, now what else can we do? Let's now work out how far up and down on the surface those points need to be. So we're disturbing them a little bit now with noise. So let's say var y2 is the old y plus some noise, and that noise depends on it depends on x and y. Now, do you remember noise creates values from 0 to 1, so this is going to be tiny, so I need to multiply that by a number. Let's say I multiply it by, I don't know, 200. That'll be quite a big range. Let's say 100 for now. Let's see what that looks like. So I'm calculating y2, the vertical position of those dots, which is the original position on the grid, but disturbed a little bit by noise. Let's see. Okay, so they've kind of moved up and down. They've jiggled it a little bit. Doesn't look like an alien landscape just yet. Maybe my noise was too high frequency. Maybe I needed to reduce it a little bit. Do you remember how we divided the parameters into noise to make them map to a smaller range? So if you're going from 0 to, well, actually we're going from 100 to 500, feeding that to noise, that's quite a big range. So if we're dividing by 200, that brings it back down to smaller numbers, which should give us a smoother kind of fluctuation. Let's try it. Yeah, you see? It's already starting to look like a landscape, isn't it? Some surface. It actually looks more like a water surface, doesn't it, at the moment? That's nice, I like that. Yeah, I like that. Really nice. I could stop there. I won't. That's really nice. Okay. Now, what else do we need to do? Looking at that noise, in fact, why don't I increase the number of dots so I draw them every 5 instead of every 10? That should add to the detail. There we go. Wow, okay, that's a lot more detail there. And you can see it does look like some kind of watery soft surface, and the fluctuations are quite smooth. Now what I'm going to do is I'd like more detail, more roughness, but what I don't want to do is, say, divide those parameters into noise so they're bigger, but dividing by a smaller amount makes them bigger. I don't want to do that, because then I get this kind of, it's entirely rough. What I want to do is keep that smooth changing surface, but sprinkle on some additional noise. And what I can do there is add more noise to the existing noise. So what I'm going to do is I'm going to say that's the height, and I'm going to increase the height again. Plus equals means add something to h. I'm going to add more noise, which is a higher frequency, so x divided by, I don't know, 30, and y divided by 30. But this noise is going to be of a smaller height, so instead of being 100 high, it's, I don't know, think of a number. Let's say 30, let's just try that. So 30 high. So actually, let me draw a picture to explain that. Okay, so the idea was that if we have low frequency noise like this, that's very smooth, we could have had high frequency noise like this. But what I wanted to do instead is have a surface which has this kind of these big features, these smooth large features, but add a small amount of roughness to them so that it kind of goes like this. So you still have the big features, but you also have these small features as well. And the way to do that is to say, I'm going to have big noise, which has, say, a scale of, I don't know, I might divide x and y by 200, and then I might multiply the height by, say, 100. But then I might have a higher frequency noise where I only divide it by, say, 20, and I scale it up by, say, 10, so it will be high frequency and not as tall. And if I add them, I should get both the big features disturbed by the higher frequency, shorter noise. Can you see? That's what we're trying to do. So I'm saying here's the big features, and here is the shorter, not as tall because it's only multiplied by 30, higher frequency noise. Now let me create the vertical height from that. Let's see what that looks like. Okay, yeah, so I can see large features and small disturbances on there as well. It's not so clear there. What I might do now is focus a little bit on making these dots not so kind of brutal in their blackness. So I'm going to use translucency. Do you remember that? We introduced it in a previous video, and it's essentially making colours see-through, but we found that when we have very detailed designs, it allows us to keep that kind of busy detail but without oversaturating the image, so we can still see detail. Again, go and have a look at that video. It's really kind of important, I think, that concept. So I'm going to switch to HSB mode because I like the way we can think about colours there. So I'm going to go colour mode, HSB. Maybe I'll make the background black before I do that. And now I need to pick a colour for these things, don't I? These circles. So maybe I'll say hue is... Actually, for now, let's not worry about what that could be. We'll just pick one colour, so I'll say fill. Let's say 0 for red. A brightness of... a saturation of 80 and a brightness of 80. And the important one is the translucency. Let's make it say 0.3, so it's fairly see-through. Let's see what that looks like now when I draw that picture. It's going to take a while. No, did it draw anything? It might be because I've still got a black outline. So I'm going to remove the stroke from those circles. Okay, you can see, if your screen allows you to, very faint surface. Let me make that less translucent. There. I'm gonna now go full whack and make that grid really fine with a spacing of 1 and not 5, so we get a lot more of those dots filled in. Okay, right, so that's pretty saturated. Let's turn down the saturation. Okay, right, we're making a lot of progress here. Now, several things we've just done, and I'll just go over them again. We had low frequency noise for the big features, the big lumps. We added to it high frequency but smaller, shorter noise to give it a rougher texture. We used translucency for those little circles so that we could put more of them on the screen but still be able to see the detail, and I think that's worked really well. I mean, this is like Mars or something, some surface of a very hot kind of planet. I think it's fascinating, this, I love it. I could stare at this for ages. It just works really well, this, doesn't it? And actually, look at that code. It's not very big at all, is it? That's pretty amazing, I think. Okay, now let's just experiment and see what happens if we removed that high frequency noise. So that's gonna, those two slashes are gonna comment out that instruction. So we're just left with a smooth surface. Let's see when it arrives. There, what a difference. So that's just the low frequency noise. What a big difference, eh? That's just the low frequency noise which gives us the big soft lumps. And now I'm going to be adding back in the smaller high frequency noise. And that gives us that kind of nicely textured surface. Now, I'm going to play with this a little bit more. I'm going to shift this up the screen a little bit because I think it's a little bit too far down, and the reason for that, I think, is I've used noise to go further downwards where I wanted to go up. If you look at the code, I've said here's noise H, which is 0 to 1, or 100 here and another 30 there, and I've made Y as big as the noise, which could, so Y2 is it's Y plus potentially up to 130 downwards. Now I wanted it to go upwards because I wanted the height to go up from that grid, so I could say actually Y2 is, let me change that to just be the noise, so let me make it taller as well, so 200. So I'm saying Y2 is the original Y minus this height, which is noise. Let's see what that looks like. Yeah. So that's taller noise. That's deeper sort of valleys and higher mountains. And the reason for that is I changed the height of the main features to 200. It's kind of going off the top of the screen there, isn't it? And that's because the noise could be as high as 130. So, and Y is as low as 100. So 100 minus 130 goes off the canvas. So maybe I'll add 50 to it just to push it back down a bit. Let's see. Yep, that's all right for now. That's kind of in the middle of the canvas. Okay, let's work on the colour now. Now, we could colour it with a different colour, not red, and that might have some interesting kind of effects. Let's see. I don't know what colour. 60s yellow, wasn't it? I think that can create an interesting design. Takes a few seconds to calculate, because remember there's lots of dots for it to lots of grid points for it to calculate noise for. That's yellow. Let's try, I don't know, 220, which I think is a kind of a deeper blue colour. Getting familiar with the HSP colour wheel. Yeah, that's a nice blue. But it'd be nice to have different colours, and in fact colour where there's logic. So maybe what we want is, let me clear this drawing. Maybe what we want is the higher the height, the more, I don't know, green or blue it is. I don't know, green maybe, or red. And the further down it is, maybe we want that to be I don't know, a blue sea, so maybe that's blue and that's red for a landscape maybe. So we can make the colour depend on the height. That might be an interesting experiment. Let's see if we can do that. So we want to calculate hue now. We want var hue equals height. Now where does height go from? Height goes from 0 to 330, doesn't it? We could use a map function. We could just map it. We could just use that, couldn't we? Let's just try it, see what happens. Haven't really thought about this. So it'll go from 0 to 130. So 0 is red, 130 is that kind of greeny? Let's see. Can't wait to see what it looks like. Okay, there's a bit of red there. You can see it's going through greens and towards blue. Let's run it again. Maybe we'll get a different surface. Yeah, you can see the further down it goes there, it's yellowy, approaching red in a way. So it's a really nice effect, this, isn't it, to have the height control the colour. It really adds to the fact that it's a landscape, and the further deeper in the valleys, the different material perhaps, and the higher the altitude, perhaps it's got snow or some different vegetation. This is already looking really good. I mean, we could just stop here. This is really effective, I think. But I think we can experiment a little bit more with colour. What if I multiplied it by 2? So it goes a full stretch from 0 to 200 and something, 260. Why am I saying that? Well, height depends on noise, which goes from 0 to 1. I've multiplied it by 200 here, and I've added potentially up to 30, so actually it does already go quite high. I was wrong to say it goes from 0 to 130. It goes from 0 to 230, potentially. What else could I do with this? I could shift it along a little bit. I could say add a value to it so that it goes around the colour wheel, or I could I could shift it back around towards the red by taking values from it. Now height minus 180 is going to make it negative sometimes, isn't it? So I need to use the mod. So I could add 360 and then modulus 360. So what this is doing is it's when I've got a small value of h, let's say 10, if I subtract 180, that's going to be minus 170. Now the colour wheel goes from 0 to 360, so if I add 360, that'll wrap it back around again, and this is just a remainder after 360 if in case it goes higher than 360. we've done this a few times before, this sort of manipulation, so do go and have a look again, or get in touch in the comments on the YouTube video if you need that re-explained or kind of talked about again. Let's try that. Okay. Now, because I'd reduced the hue values by subtracting from the height to bring them back around towards reds, you can see there's more red here. And it's nice because at the lower heights it looks blue. Yeah, so further down it's blue like it's water, and higher up it looks more sort of hot and red, hot rock. We can keep experimenting. Oh, that's a nice one, isn't it? Look at that, isn't that beautiful? Really, really nice sort of deep blue, watery kind of depths, and a really hot surface on the peaks of those mountains. That's fantastic, I love that. And just think, this amazing picture from that tiny amount of code, from such a simple idea as noise on a grid. I still kind of surprise myself at how simple but powerful these ideas are. What I'm going to do now is, I mean, we could keep messing around with different colour combinations, and you should really experiment and have a go and play. What I'm going to do is what this makes me think is, the lower the height, the deeper in the valleys it is, the darker it should be. So maybe I can make the brightness depend on the height too. So I might say var brightness equals, I don't know, height divided by, I don't know, 0.5 times 0.5. Let's see what that does. So I'm halving the height to give the brightness. So the further down it is, and the smaller the height, the darker it should be, I think. Let's try it. Let's see what that does. Sometimes I wish I had a faster machine. There's lots of calculations that it's doing, because it's doing the calculation of that colour for every point on that grid. So sometimes it can take a while. Let's see. There it is. Yeah, it's darker, isn't it? Is that too dark? I think overall that's a bit too dark. Maybe I'll change that 0.75. Yeah, okay. Yeah. We could keep refining that. What else could we do to this code? What if we changed the height of those big lumps to be shorter? Would that create us a different kind of landscape? You can do it. Yep. Yeah. So this looks really like a turbulent sea, and the heights aren't as high, and therefore it doesn't have that range of colour. I mean, it's interesting, but I think I like the other one better. So it's much higher. Yeah. I mean, I could just keep going on and kind of exploring this. Let's have another look at what it generates. Yeah, I like that. Yeah, I will stop now because, we could spend ages just refining and experimenting. What I'll do is I'll get you to do that. You really should take the code and just run with it in different directions. Maybe you can add more frequencies of noise, you can add different kinds of colours. Maybe you can even have a flat surface of the sea. Have a think about how you could do that. I think I've done my job in showing you how to create these cool alien landscapes that do look kind of spooky and alien-y, a little bit sci-fi, with just a tiny bit of code. Simple idea. I love that. It's fantastic. Actually, I'm going to make one more change. I think that goes up too high. I think it makes it not look like a square, so I'm going to change that to start at 200. I'm going to shift it left a little bit as well, just to see if that has fills the canvas better. Yeah, for me it does, yeah. So it's moved down a little bit and then just left a little bit, so it looks a little bit more like it fills the canvas. Oh, I love this picture. I might even create a copy. Fantastic. That's amazing. Yep, so you can, I'm going to click again. I can't resist. I'm going to look at another one. Come on, you can do it. Poor computer's working really hard. Wow, look at that. You can imagine yourself kind of landing on one of these planets with a kind of space probe and kind of flying through these valleys and over those kind of peaks. Amazing, isn't it? Fantastic. Okay, I really will stop there. I think that's amazing. Not because I've done anything particularly clever, but just because noise itself is so useful, so powerful, and yet so simple to use. And just using little ideas to get a kind of a pseudo perspective, a fake kind of perspective, without having to do all the calculation for projections, just having a grid that's squished a little bit to give it a kind of an appearance of perspective. And by drawing heights from further back to the front, we've created, something that looks really, really realistic in a kind of an alien sci-fi way. Brilliant. You have a go yourselves. I hope this has really excited you about the possibilities of noise. It's brought together a few ideas: loops within loops, translucency, grids, noise. It's amazing. Have a go yourselves. See you next time. Bye.